Welcome to Everything Cloud. In this video, we are going to deep dive into application load balancer. The agenda of this video is introduction of load balancer and introduction of application load balancer. First, we will see what is the load balancing. Load balancing is dividing the amount of work that a computer has to do between two or more computers so that more work get done in the same amount of time. Load balancing can be implemented with hardware, software, or a combination of both. Typically, load balancing is the main reason for computer server clustering. Load balancing aims to optimize resource use, maximize throughput, minimize response time, and avoid overload of any single resource. Using multiple components with load balancing instead of single component may increase reliability and availability through redundancy. An alternative method of load balancing, which does not require a dedicated software or hardware node, is called round robin DNS. In this technique, multiple of IP addresses are associated with a single domain name. Clients are given IP in round robin fashion. IP is assigned to client for a time quantum. Now we will see the feature of load balancer. Hardware and software load balancer may have a variety of features. Fundamental feature of load balancer is to be able to distribute incoming requests over a number of backend servers in a cluster according to the scheduling algorithm. Most of the following features are vendor specified. First feature is asymmetric load. The ratio can manually assign to cause some back-end server to get a greater share of workload than others. Next is priority activation. When the number of available servers drop below a certain number or a load get too high, standby server can be brought online. Next feature is distributed denial of service attack protection. Load balancer can provide features such as sync cookies and delay binding to migrate sync flood attack and generally offload work from the servers to be a more efficient platform. Next feature is TCP offload. Different vendors use different terms for this, but the idea is that normally each TTP request from each client is a different TCP connection. This feature utilizes HTTP 1.1 to consolidate multiple HTTP requests from multiple clients into a single TCP socket to the backend server. Next feature is health checking. The balancer removes failed server from the pools. Next feature is HTTP caching. The balancer stores static contents so that some requests can be handled without contacting the server. Next feature is content filtering. Some balancer can modify traffic on the way through. Next feature is HTTP security. Some balancer can hide HTTP error page, remove server identification header from the HTTP response, and encrypt cookies so that end user cannot manipulate them. Next feature is client authentication. Authenticate user against a variety of authentication resources before allowing them access to a website. Programmatic traffic manipulation. At least one balancer allow the user to scripting language to allow custom balancing method, traffic manipulation and more. Next feature is firewall. Direct connection to backend server are prevented for network security reason. Until we have seen basic of load balancer, now we will proceed for application load balancer. Elastic load balancer are three types: application load balancer, network load balancer, classic load balancer. Out of three, our motto is application load balancer. From here, we will start exploring about application load balancer. First topic is feature of application load balancer. Load balancer, path based routing, container application support, HTTP2 support, WebSocket support, sticky session, health checks, high availability, HTTPS support, and access log and monitoring. Now we will see the difference between the classic load balancer and application load balancer. TCP and IP supported by only classic load balancer, not by application load balancer. HTTP, HTTPS supported by both classic load balancer and application load balancer. HTTP2 only support by application load balancer. WebSocket path-based routing supported by only application load balancer. Container application support is supported by classic load balancer and it's get improved in application load balancer. Connection draining is supported by both classic load balancer and application load balancer. Tiki session supported by both. Health check is supported by both, but it got improved in application load balancer. High availability and access log and monitoring is supported by both, but monitoring get improved in applications load balancer. End of this video we'll see the application load balancer pricing model. You have charged for each hours or partial hours that application load balancer is running. The number of load balancer capacity unit used per hour. Let's see the detail. 25 new connection per second equal to 1 LCU. 300 active connection per minute equal to 1 LCU. 2.2 MB per second equal to 1 LCU, which translate to 1 GB per hours. 1000 rule evaluation per second. You are charged only on the dimension which have the highest usage. The price example that I have given the link where you can find the one example for every region. Please go on this link and check the example for better understanding. Next, we will explore more about application load balancer. Please press the ring button and subscribe button to get a notification. Thank you for watching this video. Keep learning.